Hello, welcome back to More Fun Fixing It. I've got another ZX Spectrum here today. This one was featured on a previous triage episode where we discovered that D9 had exploded, TR4 and TR5 are toast, and there's 194 ohms of resistance on the 5-volt rail. So let's just make sure that all of that is still the case and it's not magically fixed itself in the meantime. I can show you on this camera probably that D9, well, it's gone. There's not much left there. Somebody pointed out that it's still being a diode, but just in both directions. That means that TR7 is probably gone as well, so we need to investigate that. But I think what I need to do with this is, do I recap the whole thing first? It's an issue 3. It's nothing too unusual. The only things that I did spot about it that are unusual is that the decoupling caps around the memory here, half of them are these ceramic disc types, and half of them, well, not half, some of these axial black cylinder types, which is quite cute. They must have just run out halfway through and started throwing in these ceramic discs instead. I'm wondering if that diode there has got a little bit hot as well. The end of this lead is looking a bit blackened. And it's got a -6 ULA, probably the worst one, so that might be bad. We should probably test that straight away. Do you know what? I'm not sure where to start with this one. Whether to just recap. Oh, it's got one cap that has been recapped. There's a black cap there on down here in this part of the circuit. I'm really excited to announce it's PCBWay's birthday. Yes, the sponsor of this video, the legends over at PCBWay, are turning 11 years old and they're celebrating in style. You probably know them for their top-notch PCB fabrication and assembly services, but did you know they've also been supporting makers, modders and retro tech nerds like me for over a decade? And now they're giving you the presents with discounts, giveaways and birthday deals across all of their services. Do you need a PCB prototype in a hurry? Sorted. Spotted something cool in their shared project section? Go on, treat yourself. Got a 3D print your home setup can't handle? Well, they've got you covered in aluminium, stainless steel and even titanium. I mean, come on. Hit the link in the description and join the party. Happy birthday, PCBWay. Save me a slice of cake. Let's just double check everything that we think we know about this. 5-volt rail, 194 ohms of resistance. And let's check. I'm going to have a look at TR4 and TR5, which are down here. I'm just going to check for a short first of all. That was just me testing. There's no shorts. There's more resistance on the coil than there should be. So let's go to diode mode on TR4. Black lead in the middle. 0.992 is wrong. And 1.87 is wrong that way. And then with the red lead in the middle, yeah, 1.9 on the top one. And 0.5, that's the only normal reading, but that's probably still not right. Black lead in the middle of TR5, 1.6 that way, 1.2 that way, that's wrong as well, and 0.6, 0.6. It could be something else that's affecting those, but it's more likely that they've been burnt out. I don't know whether to recap this, so what I'm going to do is just put my ESR meter across everything and check for any obviously bad caps. I know I'm not using this right, but it does give me a good indication of if there's a completely bad cap. So all the caps that I would have suspected so far over that side seem to be okay. That's the highest one so far, but I think that's on the video circuit, not really that important. That cap might be slightly bad. 41 microfarads. Should be 22. 42. It could just be that it's in series, in circuit. That one's saying 100. Don't like the look of that. That's probably a bit too high to leave. I might have to, on the strength of this tester. There's a lot of capacitance in this circuit that shouldn't be there. That one, top one there, is saying 100 microfarads, and this one next to it, these are both 22s, is saying 26, but this one is saying 92 on that one. This, I think this is a 1 or a 4.7. That one's okay. This one should be okay. Yeah, that's okay. This is a 1 as well. This is a reset circuit, and that's 1 microfarad. That's okay. This is a 22, and that's 35. Oh, exactly 100. Yeah, they're both good. So do I just change the ones that are reading bad and trust this multimeter, this weird meter? Let's take one end of that out of circuit. Now what does it do? Yeah, it's still, right, so that's a true reading of its capacitance, and that's 47 and dropping because it's getting a bit, it's been a bit hot. So, but yeah, 47 microfarad is more than double its rating. So I think we're justified taking that one out. And it's at this point that I'm thinking to myself, if I'm going to take this one out, why don't I just take all the others out? So that's actually saying that that's okay. So it's saying good if capacitance is less than 200 microfarads. 16 volts. 22 at 16 should be less than 3.6 ohms, and it's the equivalent series resistance is fine. There's so many different ways to measure a cap. It's ESR, it's capacitance, actual resistance can be a factor sometimes. But yeah, that's double the capacitance or the rated value. So, okay, this one was also playing up. Let's just pop that one out as well. And this one, again, this is a 22 microfarad, and it's 43-ish, 42 and a bit. I think the ESR on this one was okay as well. Yeah, the ESR is okay on that one. Right, so the ratings on those two at least have gone way out of spec, and it's important to keep the the capacitance in spec on especially the DC circuit side of things, this part and these two. That's really important. So I'm going to change all of them. There was one over here that was not reading very well as well. So yeah, might as well change all of them. Right, here we go. Capacitors. Let's line those up over there. Get all of these out. I've got from the last video, I've already still got my issue 3 is the same. Capacitor map. Let's just whip them all out. Right, let's have a look at the capacitance of all of these first. This is a 22, and that's good. This one's a 4.7. I think this one was good in circuit. Yeah, 5.3 is fine. And that's a 1, that's okay. This one's a 1 as well. And that's okay. That was the reset cap, that one. This one is a 22. That's a bit high, 36, but probably get away with that one. These are the hundreds. That's perfectly fine. Yep, that's good. And these are 22s. 47. I think this is the one that was given a funny reading. Well, it might have been the other one. This is 27. It might have been that one. So they're all pretty much okay, apart from the ones that I took out first and a couple of the others. So no, they're not okay. Right, let's do all the 22s first. So I need 1, 2, 3, 4, 5, 6 of these. Just out of curiosity, what does one of these read? 20.4. Are they all the same? 20.7. 20.7, and that's showing 1 ohm as well on that reading of resistance. Let's put one of those. See what the resistance reading was for this. 2.7 ohms. So yeah, well, these are definitely better. I think we lost a pad here. I'll look at that in a minute. Let's get all these other ones done. Oh, and over here. All right, just going to chop all these legs off, and then I'll show you the missing pads. Actually, before I do that, I'm going to put all the other ones in, and then I'll get the microscope out. So this happens sometimes with especially with ZX Spectrum motherboards. Every now and then you'll get one that's just made of, it's difficult to describe it, but I did have a video in the past on my main channel where I had one and I said it was made of treacle or toffee or something like that. And I think and they've just like used spit to stick the pads on. So you can see those two pads have gone, Those are on the back of the 100 nanofarad caps. They've disappeared. They're not connected to anything on this side, and this is the problem. When they're not connected to anything on this side, they have no thermal mass. So this side of the caps is, they've got nice big traces, so they are more likely to stick. And there's some more there for them to hang on to. I think I lost one over here somewhere as well. That one's okay. That one's okay. That one's okay. It's this one. That end of it's okay. So I soldered this one before I realized what was going on. So you can see there the pad has disappeared on this side. Again, there's no trace for it to connect to on this side. It's all on the other side. And I think I lost one over this side as well. Yeah. And there's another one gone there. And probably both of those have gone. Oh no, just the one. Yeah, that one was missing on this one here. See, that's still not soldered. What I can do is solder it on this side, because that's the only side it really needs to be connected. There's nothing it's connected to on the other side. Like that. And that's fine. And I'll go and do that for all the other ones as well. So both of these two here lost caps on the other side. These are the 100 nanofarad ones. Hey. There you go. They look a lot better. What else? Right, I think we're in a position now to pop the TR4 out first. I'll take TR4 and TR5 out, and then we'll just test them both and see what's broken. It's a bit messy around there, so I'm just gonna and knowing the state of these pads, I'm going to turn the desoldering station. It's down on its lowest setting already, actually, so not really a lot I can do about that, but I'm not going to dwell on these for very long. Let's get them out as smoothly as possible. Just lost two pads. They've just disappeared. That's ridiculous. Yeah, this is a nightmare board. All right, that's TR5. And TR4. Let's see what my component tester thinks of these. TR4 first. This is going to be very broken. Yeah, it thinks it's a diode in one direction. And TR5. Oh, I lost a leg off of TR5. That's okay. But I'm going to replace it anyway because I think it's probably had a hard life. But lost two pads. Let's clean that up. I'm reluctant to spray isopropyl alcohol on it because I think it might just melt. So again, any places where there are pads on this side with no traces connect to them, the pads are just floating away. They're not, they're just not stuck down. Must have been a bad day at the factory. It's all right, I can live without that. Okay, I've got ZTX651 to go in TR4. So this is a drop-in replacement, so I can put it the same way round as the silk markings. Let's get a TR5 replacement. ZTX751. Oh, I think one of the holes is blocked. Is that still blocked? Oh, I think that leg is still in the hole. It is, yeah. Just see it there. Not going anywhere with that in it. Okay, so I'll solder these in as much as I can. On this side. The wire's still there, so it should actually be fine like that. But I'm going to solder them on the top side as well. It's the bottom two, and they already look soldered, but let's make doubly sure. There we go. Right. So I'm wondering if, like, TRM 8 has got a chunk out the top of it, I think. I am going to just chop that one out, sorry, TR7, and try to preserve as many pads as I can. I don't know if I'm going to be able to test this one. Yeah, that's saying that's a resistor. So that is gone. What is that? I think I can just be a BC549. I'm going to have to check that. Okay, apparently I can replace TR7 with a BC337. That's what I'm going to do. I need to check the polarity, but that's just for the sound, so I'm going to leave that for now. I just want to make sure. I needed to take it out, and it's disconnected now, so that shouldn't be causing any more problems. We can get to that in a minute. But now that I've put in new transistors here in TR4 and TR5 and replaced all of the capacitors, I can do my due diligence, do the checks again, make sure there's no funky resistance on any of the power rails, and see if this is ready to be fired up. So that's the 5-volt rail, still the same resistance. That does not fill me with great confidence. And the power rails over here, I'll tell you which ones these were, but I can never remember which way round they go. That's fine. That's okay. And I think this is the 5-volt, so that'll be 100 and, yeah, that should be high. Oh no, that's K. Oh, that's all right. Okay. So what I'm going to do is I'm going to current limit it. Let's put it in its case so it's protected from my workbench scraps. I'm going to hook it up to my bench power supply. Not forgetting to plug in the polarity the other way around. I'm going to set it to 800 milliamps. I'm not going to plug anything else in yet. Just turn it on and see what the current draw is. 619, that's okay, that's okay. So let's stick in a Steam Card Pro, and this will give us our, look in here, will give us the voltages. So 12, plus 12, plus 9, plus 5 and minus 5. All the voltages are there. Okay, let's see if we get a display. Right, what does that do? Oh, it is running. I've got no sound because the D9 has blown and TR7 is not in there. That's what fooled me. I thought There was no sound, so it wasn't working. Oh, upper RAM fails. IC17. Oh, this is going to be a disaster. IC17, which is this one down here. I have to get that out without destroying this board. So I'm going to use a method that I've never done on this channel before. And it's something I don't really like doing. And that's the destructive method. I'm actually going to cut that out in a similar way to how I've cut out the transistor down here. Just going to snip all of these legs off really close to the chip. I won't be able to test this chip afterwards. It's going to be dead. But with this board being so fragile, I don't see another way around that. If I try to desolder this chip here, yeah, look, this, let me show you on the scope. This row here and this row here are all that one hasn't got very much solder in it, are all IC17. And the only ones with traces on this side are this one, and that's it. All of these other ones, I'm going to lose every single one of these pads if I try to mess around with this chip. Looks like that's been reflowed already there. That's been reflowed, and that's been reflowed. That's been reflowed, and that's been reflowed. Somebody's been in here before. That's been reflowed. These are shiny. I reckon some of them were like this one, with not much solder on. This is a really poor quality board. Have all been reflowed. I reckon, looking at that one, big hole in that one, I reckon some of them were worse than that. And somebody's come along and put all of the factory work right, like that one. And that one and that one. That one doesn't even look soldered. It's making decent contact. Yeah, there's points all over this board that have been resoldered. Somebody has definitely been in here before me. Okay. I don't know if this is the best pair of cutters to do that with. Might need some sharper nosed ones. I absolutely hate doing this because I want to be able to test this afterwards, and short of soldering a leg on every single one of these points, I'm not going to be able to do that. I missed one. There we go, and I'm going to heat these from the top and try and wiggle out the pins so that I'm not heating up the pads on the bottom. And I'm even going to turn down, that's up. It's just over 300 degrees. So with a super steady hand, should be able to get them out like that. If you haven't got a desoldering gun, this is probably the best way to remove a chip without damage, but it's destructive. I guarantee if you use braid on this board, you would lose all of the pads. Okay, the next problem I have is to clear these holes of solder. I am going to use my desoldering gun, which isn't going to be the kindest thing to use, but I can be quick with it. And I'm going to use the gun on the top, on this side, and be quick. As quick as I can. Actually, do you know what I'm going to do? I'm going to flood each pad with fresh solder, give it the best chance. That's not working. Why is that not working? That one's cleared. Couple of holes didn't clear there, so we'll reflow those. Try again. Marvellous. It looks like we're all intact. Give that a quick clean. Got a bridge there. Just there. Oh, I haven't used braid in ages. Super light pass. If you drag across these bare traces with braid, you will take the traces off, especially on a board like this. Perfect. I'm even being careful with the cotton bud. And that was purely to make the glue tack stick, because when it's wet with isopropyl alcohol, it won't stick. So let's solder that up. Reflow, putting pressure on the back. And this side. Good. Right, just quickly test 4164. Yay. See what we get. Still no sound. Hey, clean bill of health. So all I need to do now, once I've let my cameras cool down, fix the sound by replacing D9 and TR7, composite mod it, and then I don't know if this has got, no, the keyboard membrane is shot, so I'll just button this one up and Paul will replace the keyboard membrane, and the faceplate is already falling off, so that'll be a nice easy replacement for him. And this one will be done, so I'll get those done and then we can wrap it up. Okay, so let's sort this diode and the remains of TR7 out. I have a replacement transistor, but we'll get to that in a second. I need to put a 1N4148 diode in where the remains of this one are. Right, so let's get the remains of this diode out and the remains of the transistor legs out as well. Same as the chip, I'm just going to heat from above. Ooh. I'm making an absolute pig's ear out of this. I've got the wrong glasses on, that's why I can't see. Ah, those are my computer glasses. Why would you do that? Look at that, it's like a hook on the end. Come on. Horrible things. Really would like to clear these from the top, so I'm just going to use my manual pump. Hopefully it'll clean up. Just quickly check the continuity from there to there. Yeah, that's good. And that's definitely connected. Don't think there's going to be any damage on the back. No, it looks all good. So you can see the polarity of the diode. Got to be with the mark at that end. That's a 1N4148. See, there's a 1N there, and a 4-1 there. Right. So the next thing to do is replace this transistor. Now that was a ZTX 450, I think, and actually I've got the data sheets here. Let's move that out of the way. So this is, yeah, ZTX 450, and the polarity of this is the flat side 1, 2 and 3 emitter base collector, and this is the replacement I have, which is a BC337, and the polarity is collector base emitter, so it's the opposite. So I have to put this in the other way around. First of all, I have to find where I put it. There it is. So I need the flat side facing up, like that. Right, new diode, new transistor, but what about the speaker? Did the speaker get toasted? Let's find out. Nope. Oh, 4 megohms. What? Right, so that's, I'm measuring off camera a speaker in another ZX Spectrum, and they're supposed to be 40 ohms. Whoop. And that one's measuring 42 ohms. This one is measuring 5 meg. That's something wrong with that one. Let's see if I can get this out with a manual sucker. If not, I'll walk it out.
Probably easier to measure it with this one. Yeah, that's 2.9, yeah, 4 point something. It's all over the place. But it's mega ohms. That's broken. It's a bad speaker. Okay, I've had a scavenge around in my parts bins and I found this brand new one. But I'm not going to use that. I'm keeping for a new build. And I found two other ones. This is the one, that's the broken one. This one is marked, I've written on the back 40, and this one's marked 200. I'm pretty sure it's meant to be a 40 ohm in an issue 3. And when I test this one in here, I can actually hear it making a noise. It's making a beep noise. That one's even louder, but that's, yeah, 225 ohms. So I don't need those. That's the broken one. This is a salvaged one that I can just put straight back in here. Trusty blue tack. Right, should be hearing a sound straight away. Nope. If I plug the power in. Yes. Sounds good. Okay. So the only thing I need to do now is composite mod this board. Which should only take me a minute. There we go. Perfect. It's not exactly perfect. There's a lot of noise on there, but it's working as it should be. So to summarize, we've recapped it and we didn't do anything. I did it. You just watched. I've recapped it and I've rebuilt all of the audio circuit with a D9 TR7 and a new speaker. And I've also replaced IC17 there, which went bad, and it's all good. It all seems to be working fine. The only thing that I could do with doing is putting a keyboard in it and see if it works. Perfect. There's only one more thing left to do. Oh, you get the idea. It works. Comp mod plus recap. I'm just going to put issue. That's 3, isn't it? Issue 3. Comp mod and recap. Replaced IC17, D9 and TR7 and speaker. I think that one, once I've screwed all this back together, is on the win pile and on its way back to Paul. I haven't said it yet in one of these videos, but I now am a fully paid up member of the being paid YouTubers community. And my new thing is, well, my latest thing is Patreon. And if you'd like to support my channel, you can do that by signing up to Patreon, and you'll get access to, or early access to, all of my videos. Some of them many weeks ahead of schedule. I usually batch create these videos, so there's often videos on there that are 3 or 4 weeks ahead of where they'll be seen. And there's also exclusive access videos on there, Patreon only. I just realized that I didn't put the motherboard screw in. There's also exclusive Patreon videos and updates that I put on there. I'm very active on Patreon because I'm very appreciative of the people that have signed up and that are helping me support my family. So yeah, if you'd like to come and be part of that crowd, please do find the link in the description and join in. Done. Thank you very much, Paul, for sending this one over again. I do appreciate all the lovely repairs that you've given me, and I'm looking forward to going back soon and getting some more. Right, thank you for watching, and I'll see you in the next one. Bye. Buttons.